Welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery.
And I'm Anna. It's great to have you with us. Today, we've got stories that range from NASA's next great observatory to a stunning new image from the James Webb Space Telescope. We'll also be looking at some trouble on a Kazakhstani launch pad and why Earth is so geologically unique.
Let's not wait. Anna, why don't you start us off with our first story? It sounds like there's a new powerhouse telescope getting ready for the cosmic stage.
That's right, Avery. NASA has just completed the assembly of the Nancy Grace Roman Space Telescope. Technicians at the Goddard Space Flight Center joined the inner and outer portions of the spacecraft, which is a major milestone.
So it's fully built now. When do we get to see it in action?
After some final testing, it's slated to launch by May 2027, although the team says they're on track for a potential launch as early as fall 2026. A SpaceX Falcon Heavy will carry it to its destination, 1 million miles from Earth.
1 million miles. Same neighborhood as the Webb telescope then. What's the mission for Roman? What mysteries is it designed to solve?
Its scope is just immense. The primary instrument is a 288 megapixel wide field camera. To put that in perspective, Roman is expected to gather data hundreds of times faster than the Hubble Space Telescope.
Wow, hundreds of times faster.
Exactly. In its first 5 years alone, the mission is projected to unveil more than 100,000 new exoplanets, hundreds of millions of stars, and billions of galaxies. It's also testing a new technology called a coronagraph instrument. This is designed to block out the overwhelming light from a star, allowing astronomers to directly image the much fainter planets orbiting it. It's a huge leap forward in our ability to survey the cosmos.
That's incredible. From one powerful machine to another, our next story is a bit more down to earth, and unfortunately, it involves some damage.
Damage is the polite way of putting it, though it's not as catastrophic as some would have you believe.
On November 27th, a Russian Soyuz rocket successfully launched 3 astronauts to the International Space Station from the Baikonur Cosmodrome. The launch itself went off without a hitch.
Okay, so what's the problem?
The issue was discovered during routine post-launch inspections. Officials from Roscosmos, Russia's space agency, reported finding damage to several launch pad components.
That doesn't sound good. Do they know what caused it? Roscosmos is still assessing the situation, but they've said all the necessary spare parts are available for a quick repair. However, one expert, Brian Harvey, has suggested a possible cause. He believes a combination of the intense vibration and heat from the launch, along with some improperly installed roller pins, may have caused a service tower to topple over after the rocket had cleared the pad. Right. A service tower falling over would certainly count as damage. What does this mean for future launches?
Harvey estimates it could take about 3 months to repair, likely scavenging parts from other launch pads. The good news is that the next crew handover at the ISS isn't scheduled until July, and the next astronaut mission from U.S. soil is a SpaceX flight in February, so no astronauts are stranded. However, the next Russian Progress supply ship delivery to the station will be delayed. We'll be keeping an eye on how quickly those repairs progress, but please note there is no panic, and it isn't the end of the Russian space program as has been reported in some of the more sensationalist media. It will be repaired and back in business.
From problems on the ground to problems in orbit. Avery, we often talk about light pollution for ground-based telescopes, but a new forecast reveals that even our eyes in space are not safe.
You're talking about satellite mega constellations, right? I've seen some startling images of bright streaks ruining astronomical photos.
Exactly, and it's getting worse. If the current industry proposals for about 500,000 new satellites become a reality, the problem will escalate dramatically. Projections show that by the 2030s, 1/3 of all images from the Hubble Space Telescope will be contaminated with satellite trails.
1/3? That's a massive loss of data and time for one of our most important scientific instruments.
It is, and for some newer telescopes, it's even more dire. The Chinese space station telescope, Suntian, is projected to be the worst affected. Some studies predict contamination in more than 96% of its observations, with an average of 92 satellite trails per exposure.
96%? At that point, the telescope is almost unusable for its intended purpose. It seems unsustainable. Are there any solutions being discussed?
There are. Mitigation strategies are actively being developed. They include better orbital tracking to help astronomers avoid pointing at satellites, international coordination on satellite brightness standards, and perhaps most importantly, restricting the altitudes of these large constellations to below 600 kilometers, which would reduce their visibility. It's a critical issue for the future of astronomy.
It's a stark reminder of how crowded our orbital space is becoming. Okay, from our near-space environment to our planetary neighbors, let's talk about Venus. We often call it Earth's twin, but new research is helping us understand one of the biggest differences between them: plate tectonics.
Right. Earth has this active, moving crust, while Venus is often described as having a stagnant, single-plate surface. Why is that?
An international team has developed a new framework for understanding how planets work geologically. Using numerical models, they identified 6 distinct regimes for planetary tectonics. Earth exists in what they call the mobile lid regime, which is crucial for our planet's long-term habitability as it regulates climate by cycling carbon.
The mobile lid. I like that. So, what kind of lid does Venus have?
The study suggests Venus operates under what's called a plutonic squishy lid or an episodic squishy lid regime. In this model, the lithosphere, the planet's outer shell, is too hot and weak to break into distinct plates like Earth's. Instead, rising magma from the mantle weakens the crust from below.
A squishy lid. So it doesn't move globally, but it's not totally inactive either.
Precisely. This leads to regional, intermittent volcanism rather than the global tectonics we see here. And this model actually helps explain some other recent discoveries. We've seen findings suggesting there are active volcanoes on Venus, which seemed puzzling without plate tectonics. This squishy lid idea provides a mechanism for that volcanism to occur.
Speaking of spectacular space phenomena, let's turn back to the James Webb Space Telescope. It has captured another breathtaking image, this time of a close encounter between 2 dwarf galaxies.
Oh, I saw this one. The image is just stunning. It's the pair NGC 4490 and NGC 4485, right?
That's them. They're about 24 million light years away, and they're in the process of colliding. The Webb image is so detailed, it reveals a glowing bridge of gas and streams of newborn stars connecting the 2 galaxies. The gravitational interaction between them has spurred a massive burst of new star formation.
So they're creating new stars as they pull each other apart. That's poetic. Can we tell how this interaction unfolded?
We can. By analyzing the different populations of stars, researchers have been able to trace the timeline. They suggest the 2 galaxies first swept past each other about 200 million years ago. During that pass, the larger galaxy, NGC 4490, began siphoning gas from its smaller partner, NGC 4485. That stolen gas is now fueling the starburst we see in that glowing bridge.
Incredible. It's like cosmic archaeology, a fantastic image with a fascinating story behind it. Now, for our final story, we're coming much closer to home, to our very own star. In early November, astronomers captured some extremely rare, high-definition images of sunspots in an active region designated NOAA 14274.
And what makes these images so special?
The timing. The images were taken by the Gregor Solar Telescope in Spain just 30 minutes before those same sunspots erupted, emitting a powerful X1.2 class solar flare.
Wow, that's like having a camera pointed at a volcano right before it blows. Capturing that with a ground-based telescope must be incredibly difficult.
It is. You have to be looking at the right spot at the right time, and you need clear weather. It's a rare trifecta. The images are remarkable. They show what are called penumbral fibrils. These are the filaments extending from the dark center of the sunspot that are strongly curved and braided together.
And what does that braiding tell us?
It's a clear visual indicator of a highly stressed and tangled magnetic field. Think of it like a tightly wound rubber band. That immense stored energy is a direct precursor to an explosive release, which is exactly what happened 30 minutes later with the solar flare. And this is just the beginning. Researchers are currently processing nearly 40,000 more data sets from the telescope, which could revolutionize how we predict these powerful solar events.
And better prediction is crucial. These powerful solar events can disrupt satellites, power grids, and even pose a risk to astronauts. Understanding their warning signs is vital for our technological infrastructure. And that brings us to the end of our news roundup for today. It's been another busy day in the cosmos.
It certainly has. Thanks for joining us on Astronomy Daily. We'll be back again tomorrow with another look at the latest news from across the universe. Until then, I'm Avery.
And I'm Anna, reminding you to keep looking up.
Astronomy Day.